Okay, now we worked with rationalizing the denominator. We're going to extend this lesson a little bit, and we're going to talk about fractions with radicals. Now, when we talked about multiplying in radicals, we said that we could split up a square root with multiplication, or we could bring it together over multiplication. Well, the cool thing is that that property also extends to division. And so division is really fancy fractions. And so we get this idea that if I have the square root of a over b, I can break up that square root of a and square root of b over the division. Or if I already have it broken up, I can bring that together to be able to simplify it. Now again, I have to reiterate that this works for multiplication and division. It does not work for addition and subtraction. Addition and subtraction always have different rules than multiplication and division. So it is really important that we do not try this over addition or subtraction. So how would this help? Well, what happens if I have the square root of 16 over 9? Well, I can apply the property. I can break up that square root. So now it's square root of 16 over square root of 9. And I'm going to get just 4 over 3. Now I have no more square roots, and I'm good to go. Well, how is that helpful on our next one? Square root of 3/4. So again, I can break that up, square root of 3 over square root of 4. And why is that helpful? Because now I'm not going to have a square root on the bottom anymore. So now I'll have square root of 3 over 2 because this bottom number was a perfect square. So if you have a square root of a fraction and you notice your bottom number is a perfect square, split those up and simplify it. So it's a much better one to work with. Another way that we can work this out is if I have them split up. If I have them split up, but I notice that I can bring them together. So, hey, I know that 28 can be divided by 7. I can bring them together in one fraction. And now that I've bring them together in one fraction, I can go ahead and divide. What is 28 divided by 4? Well, that is the square root of 4. Well, what is the square root of 4? That's really just 2. And so it allows us to simplify it and make these numbers way easier to work with, but still in an exact form. And our very last example for today is the square root of 1/2. And so a lot of times we don't like having the square root of a fraction. So we'll go ahead and we can split that up. So square root of 1 over the square root of 2, which doesn't really help me a lot because the square root of 2 doesn't simplify at all. But the square root of 1 does. The square root of 1 is really just 1. So now I have a 1 over the square root of 2, which brings me back to my process of rationalizing the denominator. I can't have that square root of 2 on the bottom, but I do know I can give this a makeover. I want to get rid of the square root of 2, so I times by square root of 2 on top and bottom. Then I multiply across the top. 1 times square root of 2 is square root of 2. And on the bottom, square root of 2 times square root of 2 is square root of 4. And now I have the square root of 2 over 2 because the square root of 4 gives me 2. And now I have something that I can actually work with, because now as long as I have a 2 on the bottom of another fraction, I can add fractions and combine things and keep them in an exact form. And so that's what we're going to be working with today.